Have you ever wondered how your vision stays clear even when you're on the move? Imagine yourself running, jumping, or simply turning your head. Your eyes are constantly moving, yet the world around you appears stable. This remarkable ability is all thanks to a fascinating system of reflexes working tirelessly behind the scenes. Our eyes are constantly making tiny, rapid movements called saccades. These movements would make our vision incredibly jerky if not for our built-in image stabilization system. Think about watching a tennis match. The players dart back and forth, their heads moving rapidly to track the ball. Yet, you can follow the action without any sense of dizziness or blur. This is because your eyes are constantly adjusting their position to compensate for your head movements, keeping the image of the ball stable on your retina. The human brain receives a constant stream of visual information. Our eyes are like cameras, capturing images of the world around us. But unlike a handheld camera, our vision is remarkably stable. We can walk, run, and even spin around without the world turning into a blurry mess. This incredible feat is made possible by two remarkable reflexes, the Vestibulo-Ocular Reflex, VOR, and the Optokinetic Reflex, OKR. Deep within our inner ear lies a tiny labyrinth responsible for our sense of balance. This intricate structure, known as the vestibular system, is key to the Vestibulo-Ocular Reflex, VOR. The VOR works by detecting head rotations and sending signals to the eye muscles to move in the opposite direction. This ensures that our eyes remain fixed on a target even as our head moves. Imagine yourself nodding your head up and down. As your head moves, the fluid in your inner ear shifts, sending signals to your brain about the direction and speed of the movement. Your brain then commands your eye muscles to move your eyes downwards at the same speed, keeping your gaze steady on whatever you are looking at. The VOR is incredibly fast, with a response time of just a few milliseconds. This means that even the slightest head movement is immediately countered by an equal and opposite eye movement. This reflex is essential for maintaining balance and coordination. Without it, we would experience a constant sense of dizziness and disorientation, making it nearly impossible to perform even the simplest of tasks. While the VOR excels at stabilizing our vision during head movements, the Optokinetic Reflex, OKR, takes over when we need to track moving objects. Imagine yourself gazing out of a train window. The trees and houses rush by, but your eyes smoothly track their movement, creating a sense of stability amidst the visual chaos. The OKR relies on visual cues to detect motion in our surroundings. As our eyes track a moving object, they send signals to the brain, which then commands the eye muscles to follow the object's trajectory. This reflex allows us to maintain a stable image of the moving object on our retina, even as our head remains stationary. The OKR is particularly important for activities like reading. As our eyes scan the words on a page, they make small, jerky movements called saccades. Without the OKR, these saccades would make it impossible to read, as the words would appear to jump around on the page. Thanks to this reflex, however, our eyes can smoothly follow the text, allowing us to comprehend the written word. Section 4. From Nature to Tech: Real-World Applications of Our Visual Superpowers. The principles behind the VOR and OKR have inspired numerous technological advancements. One such application is in the field of virtual reality, or VR. To create a truly immersive VR experience, it's crucial to minimize motion sickness, which can occur when there's a discrepancy between what our eyes see and what our inner ear senses. VR headsets utilize head tracking technology to monitor the user's head movements. This information is then used to adjust the virtual environment accordingly, ensuring that the visual input matches the user's movements and minimizing the likelihood of motion sickness. Another area where these reflexes have proven invaluable is in the development of camera stabilization systems. Just like our eyes, cameras need to compensate for movement to capture steady footage. Image stabilization technologies utilize sensors and algorithms to detect camera shake and counteract it, resulting in smoother, more professional-looking videos. Section 5. A world blurred imagining life without our stabilizing reflexes. To truly appreciate the importance of the VOR and OKR, imagine a world without them. Every head movement would send the world spinning, making it impossible to focus on anything. Reading would be a Herculean task as the words danced across the page. Sports would be a dizzying blur of motion. Our ability to navigate the world, interact with others, and appreciate the beauty around us would be severely compromised. We would be constantly disoriented, struggling to make sense of our surroundings. The VOR and OKR are testaments to the incredible complexity and elegance of the human body. These reflexes, working in perfect harmony, allow us to experience the world with clarity and stability, despite the constant motion of our bodies and our surroundings. They are a reminder that even the most seemingly simple actions like turning our head or reading a book are made possible by a complex interplay of biological systems that we often take for granted.